All right, everyone. Now we have Marco with us. He's going to talk about technical debt in AI research projects. Marco, the floor is yours. Go ahead.
Thank you very much. So my position paper that I will present today says technical debt in AI research projects. And before I'll go to the paper, I'd like to first discuss briefly what I mean with an AI research project. And I mean a research project, an AI project, which is carried out for research purposes, often with universities. And the first concept I would like to talk about is what such a project should produce. So usually like papers and theses, like both master, PhD thesis, and as well as presentation and demos. And there is often, this is quite straightforward, right? There is not much to talk about those outputs. But then a bit more controversial is working software. In fact, it's often believed that like research software should be like sort of free, maybe a bit spaghetti, and no quality should be enforced there to not limit creativity. But in the AI research team at H&M, we actually believe that working software is of paramount importance, maybe the most important of the output of a research project. And once I say this, then we can go to the main message, which is that we believe in the fact at H&M that agile methodologies combined with good software practices, so working software at the end, is a good way to have successful research projects. And now we go a bit in the detail. So first, agile software development in research, and what are the aspects which we believe are most important with regard to this. So the first one is fast feedback loop, often result in a controlled growth, which you don't want to have only when developing a product, but you also want to have a controlled growth in research as well, because research, we all know, you don't know how it's going to end, right? Something may work, something may not work, and that's what the game is in research. And therefore, introducing fast feedback loop and being able to control what works and not is very important. And then we believe in continuous integration from the onset, because that's the only way for us to enable some sort of stable feedback from the stakeholders. So when back in the days, you could see like those research projects where you have like all the work packages where the different developments were carried out, and then at the end, like integration. And then like that was often ending up not so well, right? With a lot of frustration and disappointment, and being able to demonstrate less than half of the algorithms that were developed in the project. And then again, like since research has a very high uncertainty by nature, we need to learn a lot, right? And we believe that the fast feedback loop of agile software development can accelerate the learning phase that goes from the hypothesis formulation to the experimental outcomes. So the agile software development will bring us a step closer to the core of research, which is the scientific method of Newton, Galileo, and Francis Bacon, right? Formulate an hypothesis, do the experiment, have your outcomes, learn something, and then go back to formulate a new hypothesis. And then, last thing regarding agile software development, but not least important, is that we believe in a mix of synchronous and asynchronous planning. So we believe for research projects, like the traditional agile ceremonies, need to be kind of heavily adopted, because you have several institutes working with different principles, different timelines, and you can't have like stand-ups every morning or stuff like that. So we work out something different for each project we are in. And then the second aspect, which we believe is very important, is the research software quality. So first, we believe in not focusing only on like the AI and data science aspects of it, but also really focusing on technical feedback, code reviews, so that at the end of the project, like we have something we can trust, not only then to exploit in production, but also like it's more and more common to have like open source code published together with papers, and then we want to publish good code that results that are trustable. Then, like a well-designed and modular software architecture, this goes without saying, because if research is very uncertain, then we need to be able to switch out entire software module for new ones. And then if you don't have a modular software architecture, good luck with that. Then another aspect is automated pipelines. We want as much as possible what comes to code quality, package build, and stuff like that. So like minimize the like manual work that researchers have to do, and this brings great benefits. And then at last, like we believe in extensive testing already in research phase. So we have in all our research projects a blend of unit test, end-to-end smoke test, and regression test to check that the performance doesn't degenerate. And with this, I mean that we don't go to look for all corner cases also in like you would do in a production system, but we mainly test the main execution of the code. But still, like there are several benefits from doing that. One of them is that by writing unit test in the beginning, like you have small and well-defined function rather than long spaghetti functions, because if you try to write unit tests for a long spaghetti function, you will end up redoing it into small ones. So to conclude, like we believe strongly in agile software methodology and software good practices for enabling success in research projects. And what's up in the...
All right,